You can't hear me, but now you can. I didn't unmute my mic. There we go. Welcome back to My Tutor Coding Squads. This is the final session. This is day 10, and we are going to be looking at data structures today in Python. So stick around if you're interested in how to use data structures in Python, or how Python works, or the computer science GCSE. We're going to be starting at 5 past like we normally do, so if you're here, just type in the chat just to let me know you're there, say how your week's been, how you're feeling. Hello there, Comet, how you doing? Oh, and the chat has disconnected. That's fun. Just to let you know, guys, we are going to be starting at 5 past today. And I'm unable to connect to chat. That is very funky. I'll see if I can try and fix that on my end, but we might just have to wait and hope the chat works. So I will just stay chill here for a couple minutes and hope that the chat works. That's real funky. Yeah, updates that we have. There is a link in the description to a form that you guys can fill out. It's a survey. I recommend you fill this one out because it's the last time you're going to be able to do it for these sessions, but it's basically a survey just telling us how we're doing, what we can improve on, if you enjoy the sessions, and if you fill out, there is a chance that you could win an Amazon voucher, I believe. I believe it's an Amazon voucher, I'm going to double check, but yeah, could be useful, especially since Christmas is coming up, if you got presents or people to buy for, so I recommend you do that. Also recommend checking out the other 2 tutor squads. We have a math squad and we have a study skills squad. Those run as well. Those will also be the last sessions this week, so I recommend you guys check those out. If you're doing maths, you're probably doing maths at GCSE. You're probably doing maths, especially if you're doing computer science. And study skills are always really useful, so I recommend you check out both of those. While I try and get the chat fixed, just to let you guys know, we are going to be starting at 5 past, so we'll start in 2 minutes. I do not know why the chat's not working there. That is very annoying. Maybe the chat's working and I just can't read it. That's even more fun. I love when things like that happen. Hopefully it'll work. Maybe it'll work just halfway through the stream. Who knows? But yeah. If you're messaging, I can't see it. Yep, chat is disconnected. I cannot see it at all. Okay. We're going to start in just 1 minute. And I still can't connect to chat. That is exciting. Oh well, it's fine. Maybe it will work sometime in the stream. I do love technology. Anyway, we will get started then. So, without further ado, I'm gonna hope that you guys can see the presentation up on the screen, because if you can't, you have no way of telling me because I can't read the chat. But yeah, welcome to my tutor coding squads. This is day 10 of our coding squads, and to show you what we're going to look at, well, as always, we'll do a recap of last time, and we're going to look at data structures. We're going to look at the basic data structures in Python and how you can use them. Specifically, we're going to look at lists, tuples, and dictionaries. And because a lot of you guys said that you liked making games, I think the most popular game that we made was the Totally Not Pokemon game. We're going to make a game today. So using the list, tuples, dictionary stuff that we're learning from today. So just to give you guys a quick recap of day 9, I would recommend, by the way, checking out day 9 if you're interested. It's a pretty useful topic. We covered reading to files and writing to files. Reading and writing files is very important in any programming, because when you're programming anything, because you will need to get your data or stuff from external files. So knowing how to do that is pretty damn important. But let's move on to day 10. So as I said before, we're going to look at 3 different types of data structures. And the first one that we're going to look at is lists. So after basic variables, which contain individual items of data, such as ints and floats and strings and bools, list is the next most common and most simplest data structure. So these data structures that we're going to be looking at are designed to hold multiple values at a time, and different ones have different properties, which make them more suitable for one task or another. Now, we've actually looked at lists before. Those were the ones that consist of a number of items. You can have just one item in it, but generally they have more than one item. These are separated by commas and contain a whole host of different things, including some of the previous mentioned data types like ints and strings, for example. I will show you how to make a list and some different things that we can do with it. So I would recommend for this part that you get up somewhere to program in. I would recommend using either idle or replit, as we've been using for the past few sessions. You can use whatever you want. It's the last session. There's no special format that you need for this particular session, so anyone will do. I'm just going to get mine up now, and then I'm going to stop for a second and let anyone who needs to get something up as well. So, as if by magic, we have idle up. Again, feel free to use any IDE or programming area in which you see fit. It's up to you, but I'm going to use idle for this last session. And yeah, so I can't see the screen, so normally I would wait for people to tell me to begin or not begin. I will just continue, and I will just take breaks where I think people are going to be needed to take breaks. Just to check, yeah, I still can't see the chat. Fantastic. So, let's look at day 10. Data structures. So the first thing that we're going to look at is lists. So let's look at first how we create a list. We've actually done this already, so this shouldn't be too dissimilar to you. So how to make a list? Well, you start it like you would any basic variable. You give it a name. So I will call it list of things. You start it with square brackets, and then each item in your list is separated for with a comma. So also, I've been told that the font is a little bit small, so I'm going to make the font a little bit bigger. I remember people were asking about that last time, so there we go. Fantastic. So yeah, I'll do my name, for example, and then I could have, you can store anything you want. Another thing that you can do with lists is you can store multiple different types in the same list. So you can store like 13, you could store, I believe you can store bools as well. but they're each separated by a comma. And I'll just quickly run that to prove that it will work. I'll call it day 10. It's fine. And if I print out that list, it works as follows. So that's a list. But having a list on its own isn't great if you don't know what to do with it. So we're going to look at a few different things that you'll need to know with lists. So the first thing is how to access each item in the list. So we use that as follows. So let's say I wanted to access the first thing in the list. Well, I can use square brackets to start where I want to access. And then the way lists work is the first item in the list is actually the 0th element. So lists start at 0. So if I want to access Fliss, the first element, I start at 0. And then it goes along like that. So let's say I want to access the 3rd element, 13. Well, I'd have to go 0, 1, 2, and I'd type for 2. So I'll make a quick note of that on the screen as well. So, accessing items, you must start at 0. In the computer science GCSE, they might also ask for arrays and where arrays start, or the array index. This is the exact same thing. It starts at 0. So if you're wondering where you've seen that before, that'll be it. So that's accessing items. You start with the name of your list and the number or the index of where it is. So again, if I wanted to access the true, that's the 3rd element, so, oh no, it's the 4th element even, so I'd write the list of things, element 3. Hang on. 0. It's because I didn't capitalize it. You have to spell things correctly. There we go, Fliss. Fantastic. True. So that's the first thing. Accessing items. You must start at 0. The next thing that we're going to look at is how to print out everything in a list one by one. So, printing out each thing in a list. We've actually also done this, I believe, already. So we can print out each element in a list using a for loop. So we can say, normally when we've looked at for loops already, we said for I in range 5, print out stuff. But you can use for loops to go through a list as well. You could say for, and then whatever variable you want, so for value in list of things. And then we can print out each value. So what it will do is it will go through the list and do something to every value. And there you go. It prints out each one side by side without any of the speech marks or the commas separating it. Let's see if the chat's come back. The chat has not come back. I will just continue. A fun thing you can do is you can also edit any of the items in the list. Let's say I had a list of numbers, and I have 3, 2, 3, 4, 5, 6. I can not only print out my list of numbers each time, but I could also do some mathematics to them. Ta-da! And now they're times by 2. So, printing out each element using a for loop. The next thing that we're going to look at is that in keyword there. So, a good thing about using this in keyword means that we don't have to go through, let's say we wanted to find a specific element in the list. Let's say we wanted to make sure that the word Fliss was in the list of things. Well, normally we'd have to go through each element in the list. Does this one equal Fliss? If so, press true. We don't have to do that for this one though. We can use in. So I can say, let's say the in keyword. I'm just going to comment these things out for now so they don't print, but they're still there. So if I wanted to check for a specific item for a list, I can do the following. If Fliss is in list of things, print true, for example. And if it's not, print false. And what this does is it saves me the trouble of having to go through each element to try and find where Fliss is. I can just say, I know exactly that it's in this list. Makes things a bit easier. In the same way that if I was to get rid of that element, it would now say false. So that's how we can use that in keyword. We can also change certain values in a list as well. So I'm going to get just, what's it called? Comment out those ones there. We can also change values in a list. So let's say I have a list of my shopping list. Let's say I have a shopping list. Things I need to buy from the supermarket. And inside I have oranges and grapes and bananas. And then let's say, actually, I want to change grapes. I don't want grapes anymore. Instead, I want raisins. Well, rather than rewriting the whole list, I can access the specific element I want to and change it. So we know that grapes is the 1 element, 0, 1. So what I can do is I can say, I'll print out shopping list to show you before and after. And then I can say, shopping list 1, let's say I want to change that to raisins. And then if I print out afterwards, it will now change. Just to further prove my point, I'm going to write print before, and I'm going to do print after. And as you can see, before we had grapes, after we have raisins. So we can access a specific one and we can change the value in the list. So that's how that works. We can also append items to a list. So let's say I'm creating my shopping list. And I decide that I want to add some more things to my list. I don't want to change anything, just want to add stuff to the end of the list. Well, I can do that. I could say shopping list dot append, and then this will add whatever I put inside the brackets to the end of the list. So let's say I want to add bread to my list, and I want to add, I should write out the actual name of the list there, shopping list dot append milk. You probably get the idea. Shopping list dot append flour. And then if I print this out afterwards, it will have the new element at the end. So if I run that program, run the program, and as you can see here, I'll make that full screen so you can see that. It goes from oranges, grapes, bananas, orange, raisin, bananas, and it adds those 3 elements there. So that's how that works. You can add things to the end of the list as well, which can be pretty useful. The last thing that we're going to look at with lists is, oh well, there's 2 more things we're going to do. We can also check the length of a list. So I'm going to stop printing this stuff out I'll just comment. Actually, no, I'll just get rid of it. No, I'll keep it. No, I'll get rid of it. I can't decide. You can also print out the length of a list. And you can do that by using the function len, so L-E-N, and then the name of your list inside, and that will print out how many things are there in your list. So if I press run, and it prints out 3, because that is what it is. There's 3 elements in the list, and that can be pretty useful as well. The last thing we're going to look at with lists is adding lists. So you can actually add lists in the same way that you would add different strings to each other. So let's say I have new shopping list, and this has some other things I want to buy. Hot chocolate, all the things I want right now, and biscuits. Now I could append each value to my first shopping list, but the other thing I could do is I could just add them together. I could say print shopping list plus new shopping list, and it will append them as if I just did append 3 times, which is quite nice. So that's a good skill to have under your belt as well. As you can see, I'll make that full screen, but it's added them all to the list as if it was appending in the first place. So yeah, that's pretty much everything to look at with lists. I'll just go through that list again, the list for the lists, one more time. But for lists, you start them by adding the square brackets, and each element in the list you'll separate by a comma. If you want to access any element in the list, remember that the list starts at 0 and you'll go on from there. You can print out each value in a list using a for loop, and you can use the in keyword to find out whether or not an item is in a list. You can change the value in the list by accessing the specific element you want and saying equals and then the new element, or you can add things to the end of a list by either adding a list or appending to a list using append. And then finally, we can look at the length of a list using len. Hopefully that all makes sense. I still don't have access to the chat, so we'll keep going. If you need a repeat of that stuff, I recommend you watch the video again. The next thing we're going to look at is dictionaries. So lists are probably the most common data structure in a Python program, but sometimes we need to use a more specialized data structure. Knowing when this is actually the case is something that comes with a bit more experience, unfortunately. So probably the most common data structure after a list is the Python dictionary. So just like a normal dictionary, we can look things up in a Python dictionary, and we do this by using a key value, which is like the word in a normal dictionary, to find the data that is associated with it. So in like a normal dictionary, this would be the definition. For instance, we might have a list of attributes for a piece of music stored in a file. There are many common formats for this, but we might extract this into a Python dictionary for ease of storage and access. Each of these items of the metadata will have a name or a category which will respond to a key in the dictionary, and the values that will go with them for the individual song will correspond to the data. I'm actually going to use this example to show you how dictionaries work. So, without further ado, let me show you how to set up a dictionary of a song. So you would start it like any other data structure. You start with the name of the data structure. In this case, it's a song. Now to start dictionaries in Python, you use the curly brackets, and then you start with your key. So I'll start with the metadata. The first metadata in a song is always going to be the title. And then the value, the pair next to it, you signify with a colon, and then whatever data that you want. So I'm going to do the song shotgun. To separate each of these key value pairs, you separate them with a Now you can do it on the same line or new line. It doesn't really matter in Python. So I'm going to keep adding some of the metadata to the dictionary, but you should hopefully see where this is going. So artist, George Ezra. Album. Staying at Tomorrow's. And then the year is 2018, I believe. So a little bit different to the regular setup that we're used to. The main thing to remember here is the key value pairs. So, first thing first, how do we actually access the data? Well, we access the data via the key in the same way that you'd look up a word in a dictionary. So let's say I wanted to find out what the artist was for this song. Well, I would say print song, and inside here, excuse me, I do square brackets and then say the key that I want, aka artist. Make sure I spell it correctly. And it prints out George Ezra. Say if I was to change this to the title, it's going to print out shotgun. So that's how that works. If I try and do a key that isn't recognized, let's say I try and say, okay, if I write shotgun, is it going to give me title? No, it's not going to do that. In fact, it's going to give you an error. It's going to be like, can't find this keyword, it doesn't exist. You only can use the key to find the value, not the other way around. So that's how you access the data. How to change the data is a different story. Well, not that different. Let's say I've changed my mind. By the way, guys, if you are messaging in the chat, I cannot see it. I'm really sorry if you guys are asking me to slow down or change anything. Yeah, I'm just going to remind you right now. The chat is just saying unable to connect to chat. Please try again later. I'm really sorry about that. There is literally nothing I can do. Yes, so how to change the data. Let's say I wanted to change the artist here. Let's say I want the artist to be me. I've written the song now. You can do it as follows. You can say song, then the name of the key that you want to change. So in this case, artist. And we're going to say equals to Fliss. And this time now, if I print out the artist, it's now going to print out me. And just to prove that I've changed it, I'll print it before the change just to show you. Actually, I'll print out the whole thing. There you go. See, it's now changed from being George Ezra to just Fliss. So, there we go. Another thing that you need to know about dictionaries is that you can have no duplicate keys. So, every key needs to be unique. If you try to repeat a key, it's not gonna like it. It's gonna get very, very angry at you. So let's say that I wanted to have 2 years. I say the year is 2018, but let's say the year is also 2019. This program is going to crash and burn. It's not going to work. It's going to run, and it's going to say, well, hang on. It shouldn't work. How is that working? Oh, I see what it's done. It's actually just taken the second key, and it's just replaced the first key. It shouldn't work, but what it's done is it's taken this key and then this key, and it's like, okay, it's just going to be the last one instead. So it doesn't work, but it still runs. But you can't have a duplicate key, otherwise it will just choose the next one over. Also, another part is about the types of keys that you can use. There are a thing called legal keys. So these are the types of keys that you're allowed to use, and they have to be immutable. So immutable means that it can't be changed while the program is running. So for example, if I try to use a list as the one of the keys, let's say list 1, 2, 3 equals 1, 2, 3. Now this hopefully should crash and burn. Yeah, there we go. It doesn't work because lists are immutable. Immutable rather. You have to use things that are immutable, such as strings or floats, stuff like that. So that's basically all you need to know with dictionaries. I'm going to slow down for a bit because I'm going to assume that a lot of you are still typing. And again, I cannot see the screen. I cannot see your chats. I cannot see your suggestions or anything that you're saying, which is really annoying. But we shall continue. But I'll give myself some breathing space. Apparently my stream is very healthy, but it's annoying because I can't even see the chat. Yep. Chat disconnected. I am aware. If anyone's wondering what programming thing I'm using, by the way, I'm using idle. This is the thing I believe that we used from like week 1 to week 6. But you can use whatever programming thing you like. You can also use Replit. I believe we used Replit for a few of the other sessions as well. The programming thing, at least for this case, doesn't really matter. You can use idle, Visual Studio, Replit, PyCharm, whatever it is that you prefer to use. I'm just using this one because I normally teach with this one. Yeah. Okay, I will continue. I really wish I could see if you want me to continue, but I'm going to keep going anyway. So the last thing that we're going to look at is tuples. I'm going to see if there's a dark mode. I don't think there's a dark mode. Oh, there is a dark mode. Oh, wow. Okay, there we go. Dark mode. This is things that I think programmers are used to using. By the way, you can use things like almost any IDE for this, by the way. So just to keep that in mind. Okay, so tuples is the last thing we're going to look at before we try and make a game out of this. A tuple is probably something you're going to be tested on, and it is a special data structure which is immutable. This means that once the values are set, they cannot be changed whilst the program is running. When the program's not running, you can change things, but when the program's running, you cannot. So this setup is so strange now. Now it's all dark, but I'm gonna run with it. So the way that you set up tuples is you start with the name of tuples, so I'll just start with val, and you use just regular brackets. And you can put items in there, so if I just do 1, 2, 3, and you separate each item in your tuple like so. So if I print out tuple, there we go. So, like I said before, this is immutable. This is a fancy word which may come up in your GCSE. Immutable means cannot be changed whilst the program is running. And to prove that to you right now, let's say I try and change number 1 to be a 4. Well, what's going to happen? Tuple object does not support item assignment. That means stop trying to change it. It's not going to work. You can print out certain values, but you cannot change them. So that's the first thing you need to know. It is immutable. It cannot be changed whilst the program is running. It cannot be changed while the program is running. So that's the first thing you need to know. The second thing is you can convert from one data structure to another. For example, you can convert from a list to a tuple. So let's create a list. I'm going to call it a list because I'm really creative. And I'm going to make it between 0 and 4. You can also create lists this way, by the way. You can use the range function, and you can just create lists. And to prove that it is a list, I'll print it out. So this is a list. Ta-da! Oh, wait, hang on. That's great. Why do we even need tuples if you have lists? Well, the reason you use tuples in case you have lists is because sometimes you want to use a data structure that cannot be changed whilst the program is running. Sometimes you might have a specific program that doesn't want things to be changed, so a tuple would be better. If you're allowing to change things, if you're allowed to change the values, then a list is better. But sometimes you want something that is immutable. Sometimes you want something that cannot be changed, and that's why we use it. What was I saying? Oh yeah, so we can also convert lists to tuples. So I can say tuple a list, run that program, and then if I print out B, it should, if I've done this correctly, should be a tuple. And it is. It's a tuple of 0, 1, 2, 3. So that's one of the things you can do. You can also return multiple values using tuples, which is something we are going to do in the last bit of the session. We can return multiple values using tuples. So let's say I have an RGB color saved in a tuple. I have the red as 255, 0, green is 0, and the blue is 144. Let's say I'm making a game and I want to save an RGB color. Well, I could put each of those values into a different variable. So I can say red, green, blue is equal to RGB. So what happens is if I want to print out just the red, well, now I can, and it's saved into that variable there. See? 255. If I want to print out green, it's going to print out 0. And if I want blue, I I can print it out like so. This is a very useful property, and we actually use this to write functions which will return multiple values. So anytime that you've used a function and it has more than one value returned, that's actually a tuple. You're using a tuple right there. That's the thing I forgot. Yeah, tuples also are very useful in functions. So for example, let's say I created a function called, I'll just get rid of this for now because it's not going to be on the screen. Let's say I create a function called getName. And I said that the first name is Fliss, and the last name is my tutor. What I can do here is in the return, I can say first name, last name. And then if I get it to save it, so I have fn ln equals getName, I can just print out the first name, for example. And I've got that out of the function. And this can be quite a useful property. If I print that out, it's just going to print out. Whoopsies, there we go. It's going to print out just Fliss. Or if I want to do the last name, we can return it like so, which is a pretty useful property. So those are the three main data structures that you're going to use: lists, tuples, and dictionaries. There are other ones as well, like sets, which can be pretty useful, but these are the main ones that you'll tend to use in your Python experience. We have about 20 minutes left. I'm afraid if you have questions, I cannot see them, and it's really annoying. But for the last 20 minutes or so of these sessions, I thought we could make a game together. More specifically, I think we can use what we've learnt with lists, dictionaries, and tuples to make Hangman. So that is what we're going to do now. If I'll quickly show you my screen. Da-da-da. Hangman, there we go. So we're going to make Hangman. So the rules of the game, it should be pretty obvious. I hope most of you who are watching have played Hangman before. I've made a simplified version, by the way. If you look up Python Hangman online, you'll find 1,000 different versions of people making the same game. But for this one, I've simplified the rules so it's a bit easier. Basically, the rules are choose a random word at the start of the game for the user to guess. Put out a string of tabs, aka the little lines there, with the number of letters in the word. Then the user will type in their guess as a single letter. The guess is then verified to check if the letter actually appears in the word. You should start here to see some of the data structures and keywords that you might want to use here. If it is correct, then the tabs are replaced by the letter, and if it's not, the user they're told are wrong. Obviously, you can add a bit more to this. You could add a score element. You could add an actual hangman made out of text or whatever. You could make this very complicated, but I've decided to keep it simple for now. So I will show you a demonstration of how you could make a hangman game. So let me just quickly set up my computer. And there we go. So to start off our hangman game, we will need a list of possible words the user could choose from. So I'm just going to call this hangman. So I'll make a words list. So this will be words that the user can guess. So I'll go with apple, banana, orange. Actually, I'll make them all lowercase. That makes things so much easier. Next, I will have a word of the game. So a word will be selected and that will be saved in its own variable. And I'll just make that a blank string for now. The next thing I'm going to do is I'm going to convert the word of the game into a list. The current word into a list of tabs. And we'll save that into a list called current word. Don't worry too much about what I'm doing right now. I'll explain a bit more as I go along. Next, I'm going to think of the kind of functions that I want to use. So I want a function for when the game starts to choose a word. So choosing a word. So I want word choice. I want one to verify that they've done something correctly. So I want verify letter. I want one if they type the correct. Oh, that should be capitalized. There we go. The correct letter. And I'll want a function if they type the incorrect letter. And I'll also want a main function as well to run the program. Okay, so let's start with the word choice one. So what I wanted to do is I wanted to pick a random word from the list. Well, we've already looked at that earlier on in this course. We looked at using import random. And what this will do is it will allow us to use the random library and allow us to pick a random word. So in here, I will say word equals random dot choice. I believe we use this in the Pokemon ripoff of words list. Next, we want to work out how long this word is, so I'll save that in a variable, and we can use length to also work out how long the word is. Next, we want to create the list of tabs. I realize I'm going a bit quick. That's because we have about 13 minutes left of this session, so I'm going to try and do this as quick as I can. Yeah, so for each letter in the word, we don't actually need to use that. I want to add or append even a tab to the word, to our list here. So that's our first thing, and I'll show you how that's going to work. So when the user starts the game, we want to save the word. Oh wait, hang on. We need to actually return something. We want to return the word that's been chosen and also the list current word. So when I start the game, I want to change word of the game. I'm using the tuple logic here and current word. And I'm going to set that to be my function here. So I can welcome them to Hangman. I also realized that there's 1,000 other ways that you could do this particular logic, because that's the novelty of Python. You can just do things in many different ways, but this is just the way that I figured out. If you found a better way to do it, more power to you. Even better. And we're going to print out the string, the list as a string. So dot join current word. And what this will do is if I run this program, we're done. Oh, I'll just uncomment these for now. And I'm not running main. And what this will do is it will print out a bunch of spaces where the user would put their guess. So that's how that works. I'm just going to get rid of this line for now. The next one we want to look at is to whether to check whether or not their letter is actually correct. So to do that, we are going to want to take in the length of the word. Sorry, we're going to want to take in the word of the game and the letter that they actually guessed. And then I'm going to write out the following code, then explain it because I'm running out of time. So we'll start with a blank list, and then we'll go through each letter as so. So we'll use a for loop for this. For I in range length of the word of the game. There should also be a survey in the chat, guys, just since this is the last 10 minutes of the session. While you're watching this, if you think that you might want to win yourself a 20 quid voucher, I recommend you give your opinion in the survey. Should be in the chat right about now. I can't see it, so I'm going to hope it's there. But yeah, so we're going to go through, we're going to use a for loop and then check to see if the letter is in the word of the game. So if the user letter is in the word of the game, for each letter, we are going to add a number to letter places. And this is just in case there might be a duplicate letter. We'll need to know where each letter that is in the game. So we're going to put I. And if at the end, if there is no correct letters, if the length of letter place is 0, their guess is incorrect, well, we'll still need to add something to letter places. So we'll say if length of letter places. Sorry if it seems like I'm rushing here at the end. I just want to make sure I finish it within the time limit. We'll append -1 because that's not going to be a number that will affect us. And then the last thing we'll want to do is return our list letter places. The next thing we want to do is we'll need to do something if they're correct. So if they are correct, then we want the letter places. We'll want whatever their guess was, so use a letter, and we'll want the word of the game. So what we can do is we can print that's correct. And then we can replace our current word, so for number in our list here, letter places. We can go current word number equals the user letter. And then we want to return current word. And then finally, we want to say if they've got an incorrect letter, well, we're just going to say that it's not, whatever they typed is not correct. So we want their user letter. And we'll print whatever they said is incorrect. Oh, there's a little thing that's cute. Now let's actually start to add all these functions into the game. I will comment these functions as well. Just to prove these functions work, we'll just use a while true loop, which means it will work forever. You can have a verifier afterwards, but I'm just going to do this for now. So while true, I want to print out the word with a space of dot join current word. I want a guess from the user, so I'll say input your guess. Then I want to verify their guess, so I want to take in letter places, and I want to see whether or not their letter is actually in the word, and whereabouts, if it is in the word, whereabouts in the word is it? So, equals verify letter, I need to go give them the word of the game, and the guess. Now, if letter places, if the first element of letter places is -1, well, we know that it's an incorrect letter. Because we said that if there's nothing in there, return -1. There we go. We know it's incorrect. And we're going to say incorrect letter. However, if it's not -1, else, they got it correct. And we want to use correct letter. This is the fastest I've ever had to code, by the way, guys. So if I do anything wrong, it's because of the speed. Letter places, the guess, and current word. Okay, I'm going to run this, and we'll see how well this works. Already got an error, that's funky. What was the error? Duplicate argument in function definition. Ah, you're right. Correct letter, I want the current word there. Oopsies. Oh, only one error. So if let's say we make a guess A, I think all the letters of A is incorrect. Let's try O. What word is it? And how have I done the logic wrong? They all have A, so I've done something wrong. Let's have a look. If I need to go a bit over to correct the game, I will. So the game is orange, so O is incorrect. Let's see. It'll be somewhere in verify letter that I've done it wrong. Let's have a look. So if for I in range, word of the game. If user letter. Oh, huh. It's because I word of the game. And then did I do it correctly here? Word of the game. Let's try that now. Oh, it's because yeah, there we go. P, L, and E. And if I type in something wrong, it's not going to work. So that's how you can make a Hangman game. So just to show how that would properly run. Welcome to Hangman, what's your guess? Let's say I guess A. A is correct. If I type in a letter that's incorrect, like Z is incorrect. And I can keep going and trying to fill out the word. And that's how you make a Hangman game. You could, of course, extend this so that you can actually verify whether you got a winner, rather than just making it go forever. You could have a live system. You could have a Hangman that actually appears on the screen. There's lots of different ways you can take that session, take that game, but that's basically how you do it. Okay, that is the final session of my tutor coding squads. I hope you guys enjoyed it. I certainly enjoyed teaching all of this. And yeah, I wish I could see any of your messages, but I'm afraid I cannot, so I'm just going to end it here. But thank you guys so much for watching, and have a great holiday.